In this video we're looking at measures of central tendency, which is often called an average. These are typical numbers that represent all the other numbers. We will be looking at three different sorts of typical number. The first one's called the mean, which is often called the average, but it's just one sort of average, and its real name is arithmetic mean. We'll also be looking at the median, which is the middle number when the numbers are sorted, and the mode, the category or number that we have the most of. All these are typical numbers, and sometimes one is better than another depending on what you're looking at, what sort of data you have. So let's look at the mean. The mean is worked out, and the mean has the symbol x bar. It's worked out by summing the numbers, and you write that by the sum symbol of x's, which means all the values, divided by n, which is the number of numbers. So for this example here, x bar is going to be the total, which is 45 when I add up all those numbers, and there are 11 numbers there, and that's going to give me an answer of 4.090909, which rounds off to 4.1. So 4.1 is a typical number for all of these numbers. And because they're in order, you can see that 4.1 is roughly going to be in the middle somewhere, so it is a typical number. In the next example, it says a data set has 50 scores and a mean of 75. What is the total? So really, someone's forgotten what the total is, but we know the other two parts of the rule. So I'll write the rule out. X bar equals the sum of the numbers over the number of numbers. We know that the mean is 75, so I can write 75 equals the total, which we don't know, and the number of scores, which is 50. To find out what the total is, we need to get that symbol by itself. So we need to get rid of the 50. To do that, we multiply both sides by 50, and these two cancel. So the sum of all the x values, or the sum of all the scores, is going to be 50 times 75, 3750. When we're working at the mean of grouped data, there's a bit of a problem. And the problem is, when we've grouped the data, we've lost some information. To show you what I mean, let's look at this first piece of data. To get 5 numbers between 0 and 9, I could have 1, 3, 5, 7, 9, nicely spread out. Or I could have 1, 1, 1, 1, 1. Or I could have 9, 9, 9, 9, 9. I don't really know which of those is right, and probably none of them are. So when we're doing this, we're going to have to do a bit of guessing. So what we do is we introduce some extra columns. This one here, the midpoint, is an estimate of what these values would be. This one here is when we multiply the two together, because 5 times this estimate would give me an estimate of the value of those 5 values, or the total of those 5 values, and when I add them up, I'll get my sum here. Because we're trying to solve this problem, we're trying to use this rule, the sum of all the x's divided by the number of terms, or the number of times we've counted something. So when I'm looking at it, to get this 4.5, what I need to do is estimate what would be a good value to use for 0 to 9. So the midpoint is a good estimate. To get that, I just go 0 plus 9 divided by 2, and that gives me 4.5. To get 14.5, I add 10 plus 19 and divide by 2. And that pattern follows down the table. To get the value of the midpoint times the frequency, I just multiply these two numbers together. So 5 times 4.5 is 22.5, 10 times 14.5 is 24.5, etc. When I total all these up and add them up, I get the value of the sum of all the x values, or at least an estimate of it, because we did guess what the values in each group were, each interval. Underneath here, I've added up all of these frequencies. So that's going to be n. That's the number of times we've collected data. So using our rule, x bar equals the sum of all the x's over the number. If I divide this one 1140 by 49, I get this answer here, 23.2. Another sort of average is called the median. And the median is the middle number when the numbers are sorted. So in this example, this first example, all the numbers have been put in order from the smallest to biggest, and I just need to find the middle one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. 1, 2, 3, 4, 5, 6. The middle number is this one here, so the median is 4. And that's a good example of, or a good typical number for that set of data. In the next example, when I look at it, I've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. Now, because it's an even number of numbers, there is no middle number. If I split it down the middle, it means that the half of the numbers are 2 or less, and half of the numbers are 3 or more. So what we do is we say 2 plus 3 divided by 2, which is 2.5, and 2.5 becomes the median. So while 2.5 is not one of the numbers, it's in the middle. With a stem and leaf plot like this one over here, the numbers are actually sorted already. So I just need to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th number is 57. And the 11th number is 60. So if I add those two together and divide by 2, I get 58.5. So that's the median for that stem and leaf. If we have categorical data, we can't add up the numbers and divide by how many there are, and we can't put them in order and find the middle number, so we use the mode. The mode is just the number or the category that turns up the most. So in this first example, even though it does have numbers, the mode would be 5 because there are more 5s than any other. In this example below, the mode is Border Collie because there are more Border Collies than any other type of breed of dog. We have looked at 3 ways of measuring central tendency, the mean, median and the mode. Now we're going to look at how they're affected when the data changes. To do this, I've picked a simple data set which has just got the numbers 1, 2, 2, 2 and 3. And let's have a look and see what happens when we actually make a change to the data, because we get some new data. To start off with, we'll just work out the mean, median and mode for the original data. So if you work those all out, the sum of all the numbers is 10 divided by the number which is 5, so I'm going to get 2 for the median, for the mean. The middle number is 2, and the one that we count the most is also 2. So our measures of central tendency for the original data are all the same. Now let's look at what happens when we add some extra data. So someone's made another measurement and we've got another number to include in our data, an extra 4. Let's see what happens to the values of the mean, median and the mode. Well, the mean is x bar, and it's the sum of the x's divided by how many there are that we've got. So we've got a sum of 14, because we've now got 14 if you add them up, and there are now 6 numbers instead of 5. And when you divide that, you get 2.3. So that means the mean has changed by the addition of 1 extra number. If I look at the median, the middle number, it stays 2. And if I look at the mode, it also stays 2. So we often find that the mean is more sensitive to change by the introduction of new data. Nowhere is this change more evident than when we look at the effect of an outlier. So let's look at the same set of data, remembering of course that originally the mean, median and the mode were all worth 2. And if you look at this new set of data with an extra 50, which is a very big outlier, way different than the other numbers, let's have a look at the effect on the mean, median and the mode. Well, if I look at the median, the middle number is still 2. And if I look at the mode, the one that we count the most of is still 2, because there are lots of 2's. But if I now calculate the mean, I'm going to get the sum of all the numbers, which is now affected by this extra 50, and takes the total to 60. And if there are 6 numbers now, that means the mean has moved to 10. So the effect of the outlier, this 50, is to make a huge difference to the mean. The mean is very sensitive to large outliers and would not be a good measure of central tendency for this data set. The median and the mode are much better. There are a lot more numbers around 2 than there are around 10.